16.3. So there's a specific type of equation that I want to emphasize because of its practical value and its practical use. Regardless of teaching, I feel I can't be without understanding what to do with an equation like this. It's an equation technically. If I have a fraction equals a fraction. (16.3). No? Yes. Anything that's fraction equals fraction, I'm going to call it a ratio equation. Because that is what it is. It's comparing two ratios. And often one of the quantities in the ratios is unknown. So I have an equation still. Let's look at a very simple example. N over 4, so n is my variable, equals 9 over 6. 9 over 6. Now, the numbers might not make the guess and check too easy, for me at least. So I do have the properties of equations to fall back on and solve for the variable. This is essentially n divided by 4 equals 9 divided by 6. And I don't want to calculate the 9 divided by 6. I want to see where the 9, 6, and 4 go in my answer. So how do I counter a division? I multiply by 4 on both sides to get n equal to 9 divided by 6 times 4, or write it like this, 9 over 6 times 4. We can put them all at the top. Doesn't really matter which one you do. I prefer the second one there. Okay. So really it wasn't a terribly difficult equation. I just multiply both sides and I get my variable alone on the left. Wonderful. Let's just do one more where the variable is in a different spot. Don't have these memorized just yet. 3 over 8, 21 over n. 3 over 8, 21 over n. So now my variable is in a denominator. Here it was in the numerator. That was very easy. So, what can I do? Well, I can write 21. I like my variable on the left. Personal preference. Personal preference. Yes?
Do you want us to leave it as an equation? Or do you want
I want to leave it because I want to see what happens to these numbers. I don't care as much about the answer as how to find the answer in a little bit. We're going to have a shortcut in a little bit. So this is 21 divided by n, 3 divided by 8. Now there are many ways you can go about this. One is multiply both sides by n. To get 21 equals 3 divided by 8 times n. It's not the only way. I'm not trying to confuse anyone. It's just whatever path you want to take, go for it. Then I can also multiply both sides by 8. I'm trying to stick to those two options as much as possible. So I have 21 times 8 equals 3 times n. Then I can divide both sides by 3. And I'm going to flip everything around because I want to write the variable on the left. It reads nicer. And I have 21 times 8 divided by 3, or in fraction form, 21 times 8 over 3. So again, the numbers in the original ratio equation feature in my answer. Now that was a little tedious. I wasn't a fan of that. Definitely don't want to do that over and over and over again. There's a very nice shortcut here. Now, I'm not a fan of shortcuts in general because they promote less understanding. But in this case, it's too handy to ignore. What I do is, we call it cross multiply. That the top of one side multiplies with the bottom of the other. and the top of the other side multiplies with the bottom of the other side. Doesn't matter which way I multiply, and then I put an equal sign between them. Now I'm not quite done, but I just have to divide by 6 on both sides in this case, and you'll see that I get my answer again, but in a much faster, convenient way. And in fact, that always works regardless of where the variable might sit. If the variable sits in the denominator, doesn't matter to me, as long as it's fraction equals fraction. I'm going to cross multiply. I put the pair with my variable on the left because I'm going to read it like a sentence. And then 8 times 21 is the other pair with an equal in between. And then the last step is just dividing by the number in front of the n to get n 8 times 21 over 3. Oh, look, that's the same. It always works as long as you have fraction equals fraction. And there are a bunch of questions that compare two ratios, essentially giving me an equation that's fraction equals fraction. So solving these guys are actually incredibly easy. I just have to set them up. And they're so easy, I literally do them in my head. Because I just cross multiply and do a little division. The answer will always only feature 3 numbers. 2 being multiplied and 1 being divided. So let's just start small with fairly intuitive, easy questions. But, you know, intuition's a relative thing. What's intuitive and easy for some is not for others. My issue is I can probably guess and check my way through these, but I'm not 100% confident in my answer. And I want to be 100% confident. Yeah.
On the quiz, in the final, obviously we would need to finish that equation for n, right?
Yeah, and we're going to do them
Okay.
because they're going to be practical problems, yes. Yeah, for sure. Yes. This was just an illustration of the cross multiplication. Now we're doing full examples. Where am I now? 16, 19. I might not finish them all today. I definitely don't want to rush through them. And we'll finish wherever we're getting to with 16.3. We'll finish tomorrow. Talk about the quiz in preparation for Monday. Then quiz on Monday. Feedback Tuesday. Quiz B on Wednesday. Then I give it back and we talk about the final exam. Ooh, it's late. I'm actually going to talk about the final exam on Tuesday because I need your opinion and I need to still send it to the printers. So I would need to do it as early as possible. But you can't really make your opinion until you've seen quiz 4. So Tuesday is hopefully enough time for that. Anyway, remind me if I just randomly forget. Your car gets 23 miles to a gallon. How far can you go on 16 gallons of gas? Now, intuitively, everyone's going to say 23 times 16. Because I have experience with it, because it's so straightforward. But let's just see how would I set this up and get the same answer. So often I take a first example where I already know the answer because it's so easy. Now I take the long route that I would need when things get complicated. So I choose a variable to represent what I'm looking for, and that is the distance I can go on 16 gallons. What do you want to call it?
N?
N. You always put N.
Yeah.
Let N represent the distance
Travel.
sure, on, what was it? 16?
Yeah.
Does travel have one N or 1 L or 2? I'm not sure. 2? You like 2? Right. I'm here to please. I don't know. It depends where you're from. Who knows? It's a math class. I don't care. Now I'm going to set this up. And how I set it up also has some flexibility. I would only suggest that you do the same thing always to get used to one thing. I'm going to match pairs based on the information. They say 23 miles go with 1 gallon. So 23 miles correspond to 1 gallon. I'm going to write it like that, because that's exactly what they said. How far can I go on? 16. So N miles would correspond to 16 gallons. It's a proportional change. So if I write it like this, I have my ratio equation right there. Put a little fraction line in, equal sign in the middle. It'll always work. Absolutely always. Now I have my ratio equation. I don't need the units, but they're nice to have. Cross multiply, because it's a ratio equation. 1 times n equals 23 times 16. And I already know that was the answer. So n is whatever 23 times 16 is. That is a good chicken. Wow. That's impressive. Anyway, what is n?
368.
368. Now we picked an easy one. We already knew the answer was 23 times 16. This just shows that this method will also work. And sometimes it's a little more complicated and my intuition is not 100%. I want this backup for my security. So you can go 368 miles on 16 gallons. Yes, it was overkill in this question because it was so simple. But I want to get used to this very handy method. Just for those cases where I am not 100% sure I'm multiplying or dividing the right numbers in the right order. Any questions on the method? Super useful, probably the most important out of all of these. 1620. 1620. There are approximately 2 pounds of muscle for every 5 pounds of body weight. For a 90-pound person, approximately how much of the weight is muscle? The thing that they're asking is pretty clear, and that tells you what your variable should represent. What do you want to call the variable? Not n.
M.
Oh, mixing it up. Is that appropriate? Muscle, yes. Let M represent the, let's say, amount of muscle for a 90-pound person. Then I have 2 pairs that correspond to each other. First of all, they say 2 pounds of muscle. Let's write it out. Muscle correspond to 5 pounds of body weight. M pounds of muscle correspond to 90 pounds of body weight. Again, this isn't the only way, but it'll always work. Don't mix it up unless you're super comfortable with this. My ratio equation is right there. Cannot be easy. Now I cross multiply. 5m equals 2 times 90. So m equals 2 times 90 over 5, which is what? 36. 36. So the calculations are also quite easy. So a 90-pound person has, these are approximations, approximately 36 pounds of muscle. If you can just, the variable that you should define is always going to be variable. If you can just set up the ratio equations, it's really so easy. So easy. And there is never any guessing. Should I multiply 90 by 5 and then divide by 2, or multiply by 2 and then divide by 5? I know I have to do something with these three numbers, I don't know which way. You don't need to know at all. Set up the pairs, the equation tells you exactly what the answer is. There's never any intuition involved. That is its purpose, to take the guessing out of it. 1621. The label on a container of concentrated weed killer gives directions to mix 3 ounces of weed killer with every 2 gallons of water. For 5 gallons of water, how many ounces of weed killer should you use? Again, your intuition and experience is different from someone else. And if you've actually baked and things like that and mixed stuff, then you have a better feel for this. But what if you don't? What do you do? This is one thing you can do. What is being asked? How many ounces of weed killer correspond to 5 gallons of water? What do you want to call your variable?
G.
G. That represents then the amount of weed killer for 5 gallons of water. Let me just double check. It's always good to double check. It sounds good. Then, what are my pairs? Well, they say 3 ounces of weed killer go with 2 gallons of water. 3 ounces correspond to 2 gallons of water. You can be more descriptive there, but okay. 5 gallons of water, well, gallons of water will be on this side. And G, ounces of weed killer, correspond to that. You can't swap these. It has to have consistency, or your ratio equation won't be correct. If I'm doing ounces here, ounces there. Gallons of water, gallons of water. Then the ratio equation is extremely straightforward. Cross multiply, 2G equals 3 times 5, so G equals 3 times 5 over 2. Again, not the only way, but I want a surefire, systematic way when I have no idea what to do. So I get 15 over 2, 7.5. So you need 7.5, let's say, ounces of weed killer. Are these easier or more difficult?
Easier.
Easier, there's a lot of consistency, a lot of repetition in definitely what you do, and the phrasing as well. Now I understand you're feeling the emotion of sadness build up because you are 2 exercises away from the end. But try and control that sadness when you realize we still have an exciting quiz ahead of us. We still have a whole final exam ahead of us. You're probably not done with your portfolio assignments, so there's a lot to look forward to. It's not the end. It's only the beginning of the end. 1622. I don't want to rush this, but we seem to be doing well. Exchange rates. Oh man, so useful. I've literally used this to calculate exchange rates. If you are buying a car costing $20,000 and you want to tell someone, or you are moving to England or something, and you want to convert that amount to pounds, how do you do it? With certainty, every time. This is a way that I strongly recommend, and I do it myself. You can do it in your head once you're comfortable. It's such a simple equation. So I have to have an exchange rate. So let's take an example. Not sure how accurate and realistic it is now. 0.64 pounds to $1 was the price of the car in pounds. What do you want to call your variable? Should probably switch the camera. Say again? Ooh, it's not up. That then represents the price in pounds. So, or then, whatever, it's making words. The exchange rate is the pair that they give you. 0.64 is the pound, simply come in front. Yes. Correspond to $1. Yes.
Of the car.
Yeah, fair enough, of the car. Fair enough. Then, Z pounds correspond to $20,000. I'll say again, many people that I've met say to me, of course you're going to multiply this with that, or divide this by that. It's obvious. It's not obvious. It's obvious to you. It's not obvious to everyone. What do I do when I'm not sure? This gives me 100% confidence of what to do, and I never have to guess. And I'm not relying on any experience or anything. This then tells me cross multiply, so Z times 1, I'll just write the Z, 0.64 times 20,000. And this tells me that you should multiply them. But given different information, or if you're given the information in a different way, that's not what you do. Yet the ratio equations are always straightforward. So what do I get here? I don't know. 12 something? No.
12,800.
12,800. So, in this simplified situation, the car would cost 12,800 pounds. You never have to guess or be unsure. Do I multiply them? Do I divide them? When do I do what? No, there's no need for that. There's no need for anything like that. The exchange rate could be given in another way, as the reverse of that. It doesn't matter. Plug it in. You can easily visualize that ratio equation in your head, which I do. Fight the emotion. Fight it. Last one. Because we're leaving out 16.4 in this case. Not in general. There are nice word problems, fancier. There's no end to the difficulty, really. But here's a good place to stop for us right now. Laptop costs $300 using an exchange rate of $1.24 to €1. How much is the laptop in euros? Last chance to represent the variable. You're going to miss it. We're not doing that in 143. You're never going to define a variable in 143 ever. This is your last chance. Who's going to take the chance? You sneaked in with a what?
Right.
Why? Just going backwards in the alphabet? Fair enough. What does it represent? Quickly.
Cost of the laptop.
Cost of the laptop in euros. Laptop in euros. Then they tell me the exchange rate, $1.24, correspond to €1. Where's the euro symbol? This side? Alright. $300 laptop would correspond to Y euros. Is that even the symbol for euros? Who knows? Then I create my ratio equation, so easy, cross multiply, and I get 1.24y equals 300 times 1, yes. So in this case, based on how the information is given, I should be dividing. The previous one I was multiplying. Who cares? The ratio equation tells me what to do. I don't need to know. What do I get? Last chance to calculate something. Well, no, in 143 we'll calculate a little bit. Not as much though.
241.
Any cents?
0.93.
Ooh, round to 2 decimals.
94.
So, the laptop costs 241.94 euros. They're there to help you when you don't want to guess, when you're not confident in that guess, when you don't have experience. Variables and equations are there to help you. You just have to know how to use them.